So my name is Austin Collins. I'm a full-stack JavaScript developer and entrepreneur. I like to get out projects, ideas, startups really quickly, get them to market. In reality, what this lifestyle looks like is every single month I'm forking over tons of cash to pay for all my various side projects and all their servers. So when AWS introduced Lambda, it really spoke to me, especially its unique pricing model, pay per use. And then when AWS introduced API Gateway, I said, this is it. This is everything I need to build an application without servers. So I immediately started refactoring one of my applications to use Lambda exclusively on the back end. And while I was conducting this experiment, a framework started to emerge, something that provided structure and best practices and principles on how to architect an app to be truly serverless. And as I continued, the framework started to be cooler than the project I was working on. So I thought, maybe some people will dig this. I'll put it up on GitHub and open source it and see what happens. So I prepared it on GitHub, put a logo of a shark on there, big shark, and I posted it on Hacker News. And I immediately became depressed because I thought it's never going to go anywhere. No one will care. It's just going to get bypassed on Hacker News like everything else on there, usually that's posted. So I went to go drown my sorrows in a sandwich, and I came back a couple hours later. And the project, this framework on Hacker News was getting upvoted like crazy. I couldn't believe it. Within a few hours, it was on the front page of Hacker News in the #2 position. Had over 300 upvotes, hundreds of comments. And in 24 hours, I'd say we got over 1,000 stars on the GitHub repo. There was something about this serverless application framework that was really resonating with people. And it resonated with one developer in particular. Probably the first comment I got on the Hacker News post was from my buddy Ryan here, who was trying to do the exact same thing, and he's now my co-founder on the JAWS project.
Hi, so my name is Ryan Pendergast, and I am a full-stack engineer, and I work for a company called DoApp out in Rochester, Minnesota. And I work with a team of 3 back-end developers, and we're responsible for managing tons and tons of applications. So like Austin said, I was also working on a tool set to kind of solve this problem, very similar to JAWS. And when I saw it on Hacker News, and after talking with Austin, it was a perfect fit to combine forces and make a killer project. So before we get into the slides and the demo, I just have 2 quick questions for the audience. This is your participation part. So question 1, can I get a show of hands of everybody who uses AWS Lambda in some capacity today? OK, so that's about 50%. Me too. Second and last question, show of hands again for the number of you who use a platform as a service play, like Heroku or Parse. OK, maybe about a fifth or something. OK, thank you. Austin, take it away.
All right. Oh, I should have switched this in the beginning. So there's me over there. I need to build apps fast and cheap. Ryan works at a dev shop where he has to manage a ton of applications, and he's got to maintain all those without hassle, hopefully. So serverless AWS is here, and this is big. You could tell this is an actual photo of developers' reaction when they first heard about this. But if you don't know what serverless AWS is, here's what we're talking about. By serverless, we mean that you don't have to think about servers. The developer doesn't have to think about servers. They exist somewhere, but Amazon has to deal with them, not you. Instead, all you're given as a developer is Lambda, which is an event-driven compute resource. It's just sitting there waiting. It's just code you deploy onto AWS to waiting to get triggered, and you're only going to get charged for the duration and how many times it's called. And then the other half of serverless AWS is API Gateway. And that's the REST API, the URL routing layer for Lambda. So serverless AWS is just Lambda plus API Gateway. And it allows you to cut out the platform as a service, backend as a service middleman. And there's one other quote I wanted to throw in here by this great analyst. He wrote this when Lambda first came out. He says, Lambda has the potential to be the focal point of AWS Cloud. I'm a big believer of that. Maybe in the future, everything you build on AWS will be using Lambda as its foundation. So why serverless? Why are we so excited here? Though Lambda runs in containers, you don't have to deal with containers. By the time I was ready to learn Docker, Lambda had just come out, and I thought, you know what? Let me hold back on this Docker technology and see where this Lambda stuff is going. Orchestration, auto-scale of containers is handled for you. And API Gateway also comes with support to help you handle distributed denial of service attacks, as well as rate limiting. And furthermore, logging, all important metrics are already built into Lambda. You don't have to set that stuff up. You can see them all in CloudWatch. So Second big reason here, why serverless AWS? It's cheaper. Now I know that if I'm going to convert all my side projects running on various platforms as a service to Lambda, I'm going to save a ton of money. But I was talking to Ryan here, I said, for the presentation, since you're managing all these apps, I'm just curious if you could take one of those apps and do a cost savings estimate to see the difference between your traditional infrastructure versus if you were to switch that app entirely to run on Lambda. And here's what he came up with.
So this is a real production workload we run at DoApp, and I'm going to do a comparison that's just raw compute. It doesn't have routing stuff in it like ELB or API gateway. So currently today, we run 2 EC2 instances. We utilize the 100% reserve capacity function. And specifically for this example, we run 2 EC2 or C3 larges for high availability across 2 AZs. And you can see it's a pretty light workload. There's about 16,000 requests a day, roughly 200 millisecond average response time. And that comes out at 3.2 million milliseconds total per day. And in EC2, that costs us about $3 a day.
And here is the Lambda version.
So as you can see, a drastic savings. In this example, the Lambda, we're running a 1042 megabyte size container or size Lambda, which is on the lower end, but not the lowest. And like Austin said, they handle everything for us: the container, the provisioning, the deployment, the HA, the DDoS. They handle everything. And as we'll get into here, it's more than just raw compute savings. It's really what we're going to talk about today is a total cost of ownership savings.
That's right. So if just looking at this real quick, there's a ton of smart people out there. There's probably a ton of smart people in this room that could optimize that top scenario, bring those costs down. But remember, that takes time, and time is your most precious resource, and that's what Lambda provides out of the box. And that's a huge margin at the end of the day. I mean, if you're an aggressive, competitive company or sort of a disruptive hacker, I think you could take on a lot of stuff just starting from here. I mean, you get started with this setup, you're pretty dangerous, I'd say. So why serverless AWS? This is honestly the biggest reason why we're excited here, because this workflow rules. And we're not just talking about application isolation anymore. We're talking about endpoint isolation. Multi-container code deployment is handled for you, and you can quickly provision new stages and regions by just copying your Lambda functions over. Super easy with JAWS. We'll show you that in a second. And all this with as little DevOps as possible.
And the little hidden gem here is, as most of you know, the most expensive part of the development cycle is the maintenance phase. And JAWS combined with API Gateway and Lambda really help address that because it reduces the friction that it takes for a developer to deploy your application in multiple stages, multiple regions, just for a function. And we'll showcase that here in a minute.
Except for one thing. And this is what I found when I started to refactor that first application to use Lambda exclusively. Serverless is also anarchy. There's a lot going on here. So what happens when you have many Lambdas? I mean, Lambda's cool. You might start hacking with it. You'll get a few Lambda functions up and running and just feel like Superman or Superwoman. But keep in mind, if you're going to build a REST API on Lambda, every single route has various methods. And all those are going to require their own Lambda functions. And it gets hairy pretty quickly. So tons of functions means tons of containers. With multiple versions, you're going to want to version those Lambda functions across multiple stages, across multiple regions, and all these are requiring their own AWS resources securely. So if you start heading down this path, this is likely where you're going to end up. Tons of swimmers all over the place. So this is where we come in with JAWS. So what is JAWS? What are we talking about here? JAWS is a free open source framework for building serverless web, mobile, and IoT applications. It's only 2 months old. JAWS takes the form of a CLI. It's just a command line tool with some simple commands that automate lots of great stuff. And when we're talking about JAWS apps or serverless apps, what we're talking about here is just a group of Lambdas. So is that still an application? I don't know. But what JAWS does, the value of JAWS, is it provides structure, automation, and optimization for rowdy serverless projects. And you can see some of our traction numbers here. So that's 4,400 GitHub stars, This was made a week ago, so I think we're almost at 4,700 GitHub stars. We have, a few 100,000 unique views and a great community. So in 2 months, there's already over 100 people who are contributing to this project. And all day long, you can find us in the Gitter chat room just trying to figure out, this new frontier. So we just released JAWS version 1. It's in beta. It's super powerful. But you're definitely looking at the bleeding edge here, just FYI. But in JAWS version 1, our goal was not just to make a groundbreaking serverless framework, but the best framework for building applications on AWS in general. So included within JAWS are AWS best practices, lots of AWS automation, reducing the learning curve and making AWS more accessible to newcomers. Honestly, I set out, just to make it my goal, and Ryan did too, to spare you from the AWS console UI, wherever possible. So people who appreciate JAWS also most are people who have done production-based workloads with AWS across regions and stages and are familiar with the pain points. And also, before we get into the demo here, I just want to show you what a JAWS application looks like when it's deployed on AWS. JAWS works exclusively with AWS. It uses only AWS resources right now. And every JAWS project comes with CloudFormation templates. It comes with 3 CloudFormation templates because CloudFormation has a 200 resource limit, and we were worried, with all your Lambda functions, maybe API gateway endpoints, and all the other resources, you'd quickly surpass that. So we went with CloudFormation because, as they say, it's a saner AWS API. We're believers of that. And you can see how JAWS works here. So JAWS is going to deploy a CloudFormation stack in each stage and region, replicating your project entirely. And I'm sorry this is so small. You can see it in our documentation. But you can see starting at the top, we have different stages. And stages are like environments. So we have a development stage, a test stage for this project. We have a production stage. And within each stage, you could easily replicate all your resources across regions. So in the production stage, we have a US East 1 and a US West. That should be US West 2. There's a little bit of a typo there. I think Lambda only works in US West 2. But within each stage and each region of that stage is a replication of your project. And you'll see the 3 CloudFormation stacks there. The first one contains your resources outside of Lambda and API Gateway. This is for your IAM policies, your IAM roles, DynamoDB, as well as an S3 bucket that JAWS uses to back up all your project data within that stage and region. So JAWS will push on every deployment. It'll save a copy of your CloudFormation template, timestamp it, and also all your Lambda functions. It backs it up to S3, as well as environment variables specific to that stage and region. So what you're looking at here is perfect replication and isolation of your serverless project across stages and regions. And let's show you how it works.
OK, so hopefully everyone can see this OK. So installing JAWS, we'll start with that. It's very easy. It's just an NPM module. So it's just install JAWS framework. And just to save time, I'm not going to do that, or actually execute it. And so let's just jump into creating a project. So JAWS, project create. And you kind of get a little welcome screen. So welcome to JAWS.
That's how you make an entrance.
And it's just going to prompt you for a few basic information here. So we're just going to take some defaults for sake of time. And you're going to enter your stage. Region, I'm going to choose US East 1. And then this step lets you choose the AWS profile, which kind of fits in with all the AWS SDK and CLI ecosystem. So if you already have profiles set up, you can specify one of those. If you don't, JAWS will actually create it for you. So I'm going to specify JAWS. And this is the part that Austin talked about where we leverage CloudFormation. So here we're creating the IAM roles, provisioning the S3 bucket for the environment variables, and the code deploys. And it takes about 5 minutes. This is a one-time cost, so you do this one time per project, per region, per stage. After that, as you'll see, it's very quick.
Yeah, this is the only spot where CloudFormation is really slow. Otherwise, deploying via CloudFormation is really quickly everywhere else, and then this keeps us up at night. So Amazon, if you're listening, any way you could speed up that process, that'd be super cool.
But we understand it's doing lots of stuff, so really slow might be a little harsh. It's you're doing a lot for us in the back end. So to save time, I've already created a project, and I'm just going to run you through the project skeleton that it creates when you create a new project. So we're going to go bottom up here, and I'll just touch on each of these real quick.
Yeah, this is scaffolding that JAWS just created for us when we ran that command.
So package.json by default, currently today JAWS uses nodejs runtime, so it just made a package JSON for us. A JAWS JSON is metadata that defines stuff about your project, the project name, the location, and of importance here, the stages. So this represents every stage, every region that's contained in this project. And at the bottom there, you can see the JAWS bucket it uses. And that JAWS bucket, like Austin said, we created for you at project create time. Admin.env, this is the way to tie your project back to the AWS profile on your file system. Specifically, it's an admin profile. CloudFormation. This is one of the CloudFormation files we create. And this contains all your resources, stages, project domains, creates the IAM roles, S3 bucket. It's all in here.
So your CloudFormation template is saved locally and then also backed up to S3 at certain times with timestamps.
And the beauty of this is if you use revision control like Git, before you do deploys, you can use Git diffs and see what's changed. So you're not only confident in what you're rolling out, but you also have a quick rollback support if you need to leverage that. And then the AWS modules, I'm going to punt on this for now. We're going to get into that here in a second.
All right, let's switch it over. So when we put out JAWS version 0, I thought like, oh, it's going to use DynamoDB and everything's going to be done this way. And of course, as soon as it got popular the next morning, the GitHub issues just piled on with all types of configuration requests that I hadn't anticipated foolishly. So we decided to take a more modular approach with JAWS, where we don't really force you to use specific AWS resources. Instead, in your Lambda functions, you could do whatever you want. And to accelerate this whole process, we've come up with something just a couple weeks ago that is really interesting called AWS modules. This acronym is awesome. So why is this so interesting here? So an AWS module is it's just one or multiple Lambda functions focused on specific tasks. It supports all AWS Lambda languages. And keep in mind, these are the Lambda functions in your JAWS project. They're just renamed to AWS modules. And now that they can support all the languages that Lambda will support, it becomes really interesting because now you can mix and match programming languages within the same application because some languages are more efficient for certain tasks. So JAWS comes with commands to build these AWS modules, aka the lambdas that your JAWS application runs on. And also, you can install these AWS modules into your project from an ecosystem that we're trying to spawn here. So in each AWS module, there's an awesome.json file which contains Lambda, API gateway, and other AWS resource configuration information. So it's kind of like NPM modules, where NPM has package.json. With Awesome, we have awesome.json. And in there, it's going to have a Lambda object with Lambda configuration settings, API gateway configuration settings, if this module needs an endpoint. And it's also going to contain a CloudFormation snippet right in the AWS module. So JAWS adds the module's CloudFormation resources to your project automatically whenever you install an AWS module from the ecosystem. So one last thing before we get into it here. My thinking here, in short, was just that, what could be cooler than just having a totally serverless application? If you're building a REST API where every single endpoint is isolated in its own container, and you're only getting charged whenever that endpoint is called. What could be cooler than that? Well, I thought if all the code you needed for your application was already written. And that's kind of the goal of AWS modules. So we started this project just a couple weeks ago, and we've already had people writing AWS modules for common tasks. We've got Stripe webhook handlers, Slack webhook handlers, transactional email lambdas. We have awesome users, which is users CRUD for your application. So what's starting to take shape here is an ecosystem of everyone sort of writing your business logic, and we're all working on this, contained in Lambda functions, and we're all working to optimize this code and work on the best possible users CRUD functions or transactional email functions. And what's sort of starting to take shape here is you're less of a programmer and more of an assembler. So let's check out these AWS modules.
Okay, so let's start off by creating a module. And I'm just going to create a hello world module. And it's pretty simple syntax. You're creating the module called greetings, and we refer to it as an action, but you can also think it as a lambda, but hello, just a simple hello world.
So greetings is the name of the module that you want to create, and hello will be the name of the first lambda function within that module. Remember, a module can contain one or multiple lambda functions.
So remember how I punted on that AWS modules directory? This is how it actually works. So you can see greetings, hello, and then there's an awesome JSON for the module. And these are the extension points that Austin talked about that get merged into your project's CloudFormation upon install. And then let's go into the Lambda directory. And again, here is a awesome.json. And this is where we do a lot of the heavy lifting for you. You don't have to touch this file if you don't want to. It should solve some use cases. But in here, we do things like the environment variables. This is really powerful because a module developer can say, for my code to work, you need to set these environment variables. And you'll see how this is leveraged in the CLI in a minute. This package object, specifically in this case for Node.js, we do the heavy lifting of browserify and minifying your code. It's very important in Lambda that your code is lean as possible, not only to encourage quicker like Node.js VM startup times, but the smaller your code base, the quicker that code gets up to Amazon, gets into the container, the quicker the container gets provisioned, and the quicker that container can start up. The CloudFormation object, this kind of describes the handler for the Lambda endpoint, as well as the runtime, and then the API gateway metadata. Okay, so let's go back here. Now we're going to install a separate module, which I've created a few weeks ago. It's an image resizing awesome module.
So we just created our first AWS module. JAWS provides a ton of scaffolding for you. A ton of best practices are built in. So if you want to start doing Lambda development, JAWS will set you off in the right path right from the get-go.
So there's a lot of stuff going on here, but I'll highlight a few things. You can see that this is an NPM module. We leverage the NPM module system to deliver our packages and maintain dependencies, but we implement a post-install hook to get JAWS hooks into the code. So you can see here there's some JAWS output. We merge in the Lambda IAM policy statements, merge in the CloudFormation resources, and then we kick off an NPM install. And you can see here the awesome images module requires a few packages. And you'll see this warning that says, hey, like I said before, module implementers can say which environment variables need to be set to make this code work. So we're going to do, after we've installed it, we're going to deploy the resources. And all this is doing is executing your CloudFormation resource file, now knowing that we've just merged in all that stuff from this new AWS or awesome module.
Yeah, installed a remote awesome module. It comes with CloudFormation templates specifying your AWS resources. JAWS merged that in immediately on installation, and now we have a JAWS deploy resources command, which is going to provision that stuff on your AWS account. And some of the stuff might cost money, just FYI. And you can see we're provisioning it within the stage and in a specific region within that stage. So this is the development stage and the US East 1 region within the development stage.
Okay. And then I'm going to show you the JAWS env command. So I'm going to list all the environment variables for my development stage across all regions. And if you use Heroku, you may be familiar with their env command. This is similar, but with a few more features. And you can see here highlighted in red the awesome module, the awesome images resize module said that I had to set image resize bucket. I haven't done that yet, so it's told me that in red. So let me set that here real quick. So I'm going to set that environment variable for that region, for that stage. We also have helpful utilities. You can set it for multiple regions at the same time. Okay.
So real quick before we deploy this,
Oops, I got to switch over.
just to talk about some stuff he touched on lightly. AWS Lambda comes with a cold startup cost, especially for asynchronous Lambda calls. And this just happens when your Lambda function on AWS hasn't been called for several minutes. AWS is going to deprioritize it in their infrastructure, and it's going to take a little bit longer on that first initial request. So we've been paying a lot of attention to this and focused and really provide a lot of optimization right in JAWS. Because if we're talking about building web apps, mobile apps, lots of stuff, we need those fast response times. And so JAWS out of the box comes with a ton of optimization. And whenever it goes to deploy a Lambda function, here's what JAWS is going to do. It's going to package and optimize your code. It's going to run it through browserify to concatenate everything, traverse up the dependency graph, bring everything into one file. It's going to minify it. And then it's going to upload the compressed and time-stamped Lambda to your S3 bucket in that stage and region, so you have a backup of that specific deployed Lambda. And then it's going to update the CloudFormation Lambda template within your project with the S3 keys to where that Lambda function is located. And then it's going to update the CloudFormation stack in the stage and region to deploy your Lambdas. In short, JAWS deploys Lambdas via CloudFormation. But it does all that stuff behind the scenes whenever you deploy your Lambda functions to give you the best possible response times. Oh, deploying endpoints with JAWS. So API Gateway is really powerful, but it's pretty new. And CloudFormation does not have API Gateway support as of yet. So JAWS fakes CloudFormation syntax. Our strategy here is just fake it till they make it, I guess. So the point of this is that whenever they do introduce CloudFormation support for API Gateway, it should be pretty easy to transition your JAWS project. Hopefully, you won't even notice it. Another thing is we had to build our own API Gateway SDK in Node, and I took on that project. It took me like 3 weeks, but it deploys your whole REST API for you. So when you deploy something with JAWS, it's going to optimize your Lambda functions for best possible response times, back them up onto an S3 bucket, deploy them on AWS in a stage in a specific region. And then if your awesome JSON contains API Gateway configuration settings, JAWS is then going to go deploy that endpoint for you and connect it to Lambda. So let's see what this looks like.
OK, so let's deploy something. We're going to use the dash command. That's short for dashboard. As you can see, it's traversed the project. It's identified all your Lambdas, and that's the L. And it's identified all your API Gateway endpoints. That's the E. And we're going to deploy all four of these things at one time.
And this is something we came up with. This is needed for serverless projects in general, this dashboard, because you have configuration settings specified all over the place. We wanted a way to centralize all that information so the developer can view it and deploy off of that quickly.
And I know this kind of looks like a GUI, but we also have command line options to run this without user interaction. So every command you see that's interactive is also a command line option alternative as well. So it's doing a lot of stuff here. This is really the heavy lifting of JAWS. Like Austin said, we're running it through browserify, minifying it, downloading the env file for the stage and region from S3, zipping all that stuff up, uploading it to S3, updating your CloudFormation, and executing the CloudFormation. And you can see all four, and the API Gateway. So you can see both of those endpoints, both of those Lambdas were deployed before we could finish talking here.
Yeah, it usually takes about 30 seconds to do a deployment. Doesn't matter. We haven't seen, even if you increase the amount of Lambda functions, it doesn't matter. CloudFormation will deploy all that in about 30 seconds. And what's spit out here is a URL. This is your REST API that was created for you via API Gateway.
OK, so let's try this out. So we're going to do the hello world one first.
So in that Lambda function that we created in our project, we specified in the awesome JSON, there was a path property where you could specify the route if you want to hook up a URL to the Lambda function. And that's what he put in here at the end. Let's give it a shot.
Bam.
There we go. By default, it returns this, this JSON response here. But I don't know if anyone's done a lot of Lambda development or API gateway development yet. This is pretty powerful. I mean, it takes a long time to set up your API endpoints and stuff in the console. And JAWS just did all that stuff in a matter of seconds and deployed it for you.
OK, now let's try the image resize. That one is images thumbnail. We like Jeff Barr, so we're going to use him as an example. And so what this is doing is downloading that URL, or the data backed by that URL. It's resizing the image, uploading it to an S3 bucket, and just to prove it's not vaporware, there's Jeff. So as I suspect many of you can appreciate, this design and developer flow compared to the traditional EC2 code deploy flow, right? We did a real working project. We leveraged the open source community, the awesome modules. We deployed, this could have been a production workload in seconds, minutes, right? And Austin could check out my project, fork his own branch, create his own stage in like 30 seconds. So very powerful stuff. Okay.
We're going to check out one more thing. Yep, we want to show you one other thing, just to show you how powerful the JAWS optimization pipeline is. Let's take a look at what the file sizes of our lambdas in the console here.
So we have two lambdas. The one I'm going to showcase here is the awesome images thumbnail service. And as you can see now, the optimized package is 798K. That's all the heavy lifting JAWS has already done for us by default. And what I'm going to do is go into the awesome JSON for this lambda. And I'm going to flip one little bit here, or one string, and just make this false, right? So we're not going to optimize or build the nodejs package. And there's a lot of flexibility in here. I'm not going to go into it today, but there's packages you can exclude, like the AWS SDK, which is not browserfiable. So we exclude that, and you can also do include paths. It's a little more advanced, but we do have support for that. Okay. So now we're going to do so you'll note I'm not using the oops.
Just use a dash. Yeah.
And I'm just going to deploy the lambda.
In short, we made a change to the lambda function, and now we're just going to deploy that. Turn off the optimization.
And you'll see it's not echoing the statements about compiling the code. So it just made the zip file from the code and downloaded the env file, put it in the zip.
So what was the original file size when it was optimized? It was almost 800 kilobytes?
So bam, 2 megs.
Right. So that's big. Yeah, I don't know the particulars of how AWS fires up these Lambda containers, but I believe that they have to first transfer the code base somehow and then spin it up in a container. And I think downing the file size helps both of those. So real quick, we just want to give you some practical advice about optimizing your Lambda functions in particular. The first best tip we have going for you guys is that your Lambda function should be a thin wrapper around your own separate modules to keep your code reusable, testable, and AWS independent. Whenever you make an AWS module with JAWS, it's going to do this. It's going to give you a handler.js file that just is the file that Lambda will call, but it's going to keep all your code outside of that in an index.js file. What we're trying to do here is recreate traditional sort of application framework structure. Second tip here is keep your deployed code footprint small as possible. JAWS does that for you as well. Keep module requires outside of your Lambda function handler. And then the last and most important lambda optimization trick, if you don't know this already, this is where we see the best performance and improvements, is just increasing your lambda's memory size, especially if you have a lot of infrequent visits or traffic to your application. Increase your lambda function memory size, because when you increase the memory, you're getting more CPU. And then dial it down when you have more traffic, because those lambdas are already going to be warm, hopefully, and you won't have to deal with that startup cost. So we touched lightly on JAWS. We didn't get a chance to go into replicating your stuff across a region. It's just another command. Or creating a new stage, also just another command. But this is the grand vision here. You instantly create a JAWS project, select from tons of pre-written AWS modules to rapidly build your application. We just installed one that already did image resizing stuff. Deploy all your functions at once or one function at a time for easy updates and maintenance. I mean, the bane of my existence as a developer is just a big interconnected code base. If I touch one thing over here, it's going to affect this thing all the way over here, or several things. But we have complete endpoint isolation here with lambda and serverless architectures. Deploy to all regions. Why not? It's cheaper than ever before. Again, whenever that stuff is going to get called, you're only going to get charged at that point. And maybe AWS will build some type of latency-based routing for API gateway.
And then one more thing I think we forgot to touch on is another grand vision is to have multiple runtimes within the project. So any runtime that Lambda supports, you'll be able to mix and match the runtime that best suits that solving that problem. So if you want to mix Java with Node today, you can do that.
And the goal is perfect serverless applications, cheap as possible, monstrously scalable. So that's the future we're racing towards. Real quick, I just want to give a shout out to the open source contributors. I don't know if we would have made it this far without them. All these guys are trailblazers and super great people. If you can't get a hold of Ryan or I, hit these guys up. These are their GitHub usernames. And also, I was shocked putting this open source project out there. I didn't expect to really hear anything from Amazon. Wasn't sure. But we've had a ton of AWS engineers come forward and talk to us about best practices and how to do this best so that it's aligned with Amazon.
And we forgot Stefano on here. He's the API gateway guy, so he's helped us out as well.
Yeah, that's right. Actually, Stefano is on the API gateway team. But real quick, Amazon gave me this special edition hoodie for the JAWS project, and I made this JAWS video last week, which they really liked. And it's pretty slick here, I think. And I showed it to Stefano on the API gateway team just yesterday, and he laughed at me. And he said, "I'll pay you $100 if you wear that during your breakout session." I was expecting this to say NASA. Yeah, Stefano, you just didn't specify how long I had to wear it for. So if you run into Stefano on the API gateway team, just ask him to buy you a beer and put it on Austin's credit. So JAWS framework just redirects you to the GitHub repo for now. If you have any questions, we'll hang around for as long as it takes to answer all of them. Here's our contact information. Again, it's just a free open source project, and our goal is just to build the best serverless application framework out there. So hopefully you guys will dig into it.
Thank you.
Thank you.
Thank you.